Hello everyone, my name is Mateusz Mróz. I am PhD student at Astronomical Observatory of University of Warsaw. And I will talk today about analysis of one of the events with Xallarap effect from 2017. I will give really brief introduction to OGLE project that I'm part of, and I will describe two microlensing events, including one with the Xallarap effect, and I will say a few words about the transiting planet in galactic fields. So, optical gravitational lensing experiment, it's a project that started over 3 decades ago. Since '97, we used the Warsaw telescope 1.3 meter one in Las Campanas Observatory in Chile. Beside the traditional microlensing fields like galactic path and underlying system, we also monitor on a regular basis galactic, extended galactic disk. So, yeah, you can see over here our camera, one of the frames. It's 1.4 square degrees. This is our telescope. You can see its localization in Las Campanas. So whenever you will have a chance to visit Las Campanas, please come and visit us as well, because it can get really long over there. And we are, as I said, it's a long-lasting project. We are reaching soon 8,000 observations. Yeah, I will say some few words about the event that you can see over here. Was first published in the Planetary work from 2001 concerning the occurrence rate of white orbit planets. It was not fully analyzed in this paper, and that's why I started working on it. This unique event because the shape of the light curve cannot be explained without the involvement of Xallarap effect. As you probably know, the Xallarap effect is orbital motion of the source. You could orbital motion of the source. You can add it to the modeling with 6 Keplerian parameters. The problem with it is that you can find many orbital solutions of the Xallarap that will produce different factors, but still will explain well the photometric data. And for this, although this event has like really strong signal from the Xallarap, still you can see this problem. Of the source orbit, but obviously the all parameters are there as well. So in such situation, I use this traditional step-by-step approach. I excluded the planetary anomaly at first, split my models into 10 overlapping period ranges of the Xallarap, and then add the Xallarap parallax. And I end up at this point with 20 different samples of optical stereo, and to not lost any out of this degenerate solution, I started experimenting with the Planetary algorithm on the posterior to finally choose the right orbital solution for the modeling of the planetary anomaly. So I end up choosing the skinny clustering algorithm. There are plenty of the clustering algorithm. This is one of the more modern ones. The advantages of it is that it performs deep tests of unimonodality, but it performs on the empirical cumulative distribution function. This means it doesn't calculate any distance as means. That's why it's really fast and highly noise robust. And here you can see the result. Those points represent the model with the lowest chi-square statistic in each identified cluster. As you can see, there are still some clumping, but at this point of the modeling, I'm not worried that I will have too many solutions. I would worry that I would miss one that could lead to the right model when I incorporate the planetary anomaly fitting. And those are really early results with the planetary anomaly fits over here. As you can see, it's my unique event. And now I'll switch to other event that I'm finishing analyzing. I was presenting on the poster last year, so maybe some of you remember. It's an event with the planetary anomaly bump-like close to the main peak that it's well sampled in both MOA survey and OGLE survey data. And what is interesting, the results of fittings that all the topology of the event of double source, double lens models, pointing out or like suggesting at this point low mass or substellar host of the planet. And since it's pretty old event, hopefully we will be able to somehow verify this soon. Yeah, and it's a bit off topic over here, but not completely, I would say. So I was also able to use the already made data of the OGLE project in the galactic bound field to identify the transiting planets. I was able to identify 99 transiting planets in our most densely observed fields. And as you can see, I believe it's a sign or like it's worthwhile to look for the transiting planet in the data that we collect. Because, for example, we can kind of close the gap in, for example, galactic distances between the microlensing planet and transiting planet in galactic bulk fields. And that's it. This is part of my just like side note. This should conclude my PhD thesis, and I will continue.
Nice work. For the event with the Xallarap, is it bright enough you can follow up with spectroscopy to have radioactive constraint or something?
No, I would say that it would be impossible. At least, like in it's doable, yes, but to get the time on the telescope to measure it would be like, yes. I'm saying impossible because I have like 100 almost transiting planets in the same field with same brightnesses, and it's not so easy to get by.
What is the expected amplitude of the radial velocity of the binary for your best solution?
Yes, so I didn't identify the best solution. As you can see, all of them can be at this point possible. So obviously with like 600 days, the signal would be impossible to detect.